Hi Cool to Clem. This is a specific video about your radio that you made, or your superhet that didn't work and it made you kinda angry. I've rebuilt it and I've written you a message already, as you probably have seen, and this is pretty much your circuit. So here are the 2N3906. Here is this tuned tank circuit, and this is already the improved version. As I said, I've made some changes. In your circuit you have from the emitter one resistor and one capacitor, and then you have let's find another resistor in series, so like this, okay? But the problem is the RF will go over this capacitor. The capacitor is shortening the 1K resistor, but there's still this 1K resistor here left. That's the first thing. So what you have to do is you have to take one capacitor that goes from the emitter to plus, because you want the RF to be low impedance on this thing. The other thing is that you want to add a parallel capacitor from plus to minus, like 100 nanofarads, because everything becomes unstable if you don't add this capacitor. So the other thing that I saw is the working points that you were using. You had this BC548, which is there, with a 10K from collector to plus, and then you had 220K between base and collector. That's too less. You want to have like 1 mega ohm there. And also the problem is that this thing is not having too much gain. Your circuit basically does work, but the problem with your circuit is that it does have not much gain. Okay? So you want to have a high gain circuit, because we are picking up a low power signal on the antenna and you want to amplify it. If you're using like 1K there on the emitter, or at all 2K, where by the way the 220K working point is alright, but if you're using this resistors, you get like a high power, if you want to call it like that, IF amplifier, and you don't need that. What I've done is, I'll show you in the next video, give you a schematic what I've changed. I've tried to keep your circuit. So basically I've changed the two resistors to like one resistor from the 2N3906 emitters to plus, and one capacitor in parallel. And the resistor is 22K and the capacitor is 100 nanofarad. But they will work any value from like 10 nanofarads up to 100 nanofarads. That was what's lying around. I've also changed the input amplifier to a much higher impedance circuit, and the resistor where you're using 10K I've replaced with 68K, and the 220K I've replaced with 10 mega ohms. But you probably can use like 33K up to let's say 150K or so, and you always have to you should measure the voltage, and it should be around a half battery voltage. So if you're supplying it with 9 volts and you measure the voltage from the BCA548's collector to minus, it should be around 4.5 volts. But there's another change. Here is the diode, which you have connected directly to this circuit, which is basically not a bad idea. But I've made a version that has more gain. And what I've done is I've disconnected the diode from the tank circuit, and I've placed a 1 nanofarad capacitor between the tank circuit and the diode. This could of course also be like 3.3 nanofarads or 10 nanofarads, but keep in mind that loading this thing will also change your resonant frequency, so you may experiment a little bit with the parallel capacitors. And then I've added from the diode, which is now AC coupled, it's AC coupled, I've added a 1 mega ohm resistor from anode to plus. So the diode is already conductive, although there is not yet an RF signal flowing over it. From cathode to ground, I've added a 10K resistor, as I wrote in the message, in parallel a 100 nanofarads. I left this 100 nanofarads, I just changed the 100K to 10K. Then I took a 3.3K resistor, where is your audio output, and a 100 nanofarad capacitor in series, and added another simply BC548 audio amp. That gives me like a line level signal. So we have 10K from collector to plus and 1 mega ohm from base to collector. So that's my audio amp, and this is just an LM386, definitely nothing special. Here the circuitry that you can see here is my local oscillator. So you have your own local oscillator, I made another one. This is just that I can show you this video. So Clem, I don't want to make you another schematic, because I basically just can explain what I did. So I changed the two resistors that you have in series on your original circuit. So it's like your original circuit is looking like that. you have two resistors in series, and one is there's a capacitor. No offense, but this is not that good. I changed it to like one resistor and one capacitor in parallel. I'm using 2N3906 just as you, and the resistor that I now built in is 22K, and the parallel capacitor is 100 nanofarads, but it could also be like 10 nanofarads, something from 10 to 100 nanofarads. I changed the input amplifier. You can eventually leave it with 10K, but you have to replace the 220K to at least 1 or 1.5 mega ohms. But I rather recommend a higher resistor than 10K, because keep in mind that you're picking up a low level signal here, and if you're having a not so much gain amplifier, it won't be amplified that great. And also, I'll show you that in a minute, I've added an input coil. This is not a tuned circuit. So for example, if I want to receive 49 meters, you can add a coil from like 20 to 30 microhenry. This one's having 27 microhenry. That you get at least a rough selection. This is not a pre-tuned circuit. You can add a coil, this is not tuned. And another thing is, I've added between the base and the antenna, I've added a 10 picofarads capacitor. As I said, if you add a too big one, you won't get any selectivity, but if you add a small one, you will have some selectivity. I'm not sure if you can hear it if I turn it on, but there are already two stations mixing. Currently there's a German amateur radio broadcast. So the German amateur radios are renting a transmitter in Austria, and they are broadcasting with 100 kilowatts. They are having a 1 hour broadcast on about amateur radio, vintage music from the gold time of the radio, as they say, and amateur radio news. Of course, you won't understand it because it's German if I turn it on, but you will see that the receiver is working. But I try to keep everything else you have. I keep the 220 microhenry, 470 picofarads, and so far and so on. I mean, you need to do these changes because the circuit here with the resistor and the capacitor is basically a good idea, but you still have the 1K in series, which costs you a lot of gain. Okay, I'll turn it on now, and you will be able to hear the German amateur radio station. Oh, that's a rental station in Austria, but you will hear the radio program from the German amateur radio operators. So you can hear there are two stations. The music is the amateur radio, and the talking is another station, so there is not much selectivity. That's because you need an input selector. So it's like you have the IF, and if I took my receiver, where aren't any batteries in currently, I could show you that it's I have tuned this to 470 kilohertz, and if I hold the antenna close to this, you can hear it. So it's working basically. So as I said, you are on the right way, Clem. You are on the right way with your superhet receiver. I'll try to tune it in a little bit better. So you can hear there's KBC radio, and at the same time there's the amateur radio stations. So you can hear two stations at once, because there's no input selectivity. So the stations, the German amateur radio station is on 60-70 kilohertz, and KBC is on 60-95 kilohertz, or kilocycles. So we're having 25 kilocycles between both stations, and they aren't really selected that good. So now I'll show you what happens. Now we have, as I said, I've changed this. You had rather a low gain amplifier, and I changed it to rather a really high gain amplifier. And now I'll show you what happens if I pull out the coil. So because what I've also done is I've added an input coil, as many people wrote in the comments and as I've told you. Now we have a high gain amplifier, and yeah, a high gain. I pull it out. And this is pretty much what happens, because what then happens is that this gain here jumps up, and it's receiving the I frequency and it's receiving the LO frequency, and everything's mixing up, and everything it's doing is, as you could hear. If I turn down the volume, it will get a little bit more silent, but it will stay. So you really have to add an input coil clamp, because on your system you don't have this fuzzing or buzzing noise, because there is not much gain on the overall gain is. It's like, this is really like 100 times more sensitive than your receiver, but it's basically the same circuit. I've just changed some resistors and capacitors. So I'll turn it on again. That's German, that's the amateur radio station. And you can hear the music. That's mixing up two stations. I try to fine-tune it. That's the German station.
Jugendarbeit und Spaß an der Elektronik. Kontaktieren Sie den deutschen Amateur-Radio-Vertreter.
So this is pretty much a commercial what is being transmitted. It's talking about the German Amateur Radio Club. You can get some books there, you can get some learning stuff. Just contact the DRSA club and so forth. And so they are advertising for amateur radio. So anyway, as you could see, Clem, the superhet receiver is basically working. So I'll once again explain the changes. Take out two resistors and replace them with one 22K and one 10 nanofarads or 100 nanofarads, something in that range. You can also use like 10K to 22K. So what's laying around, Clem? The base collector resistors there are 2.2 mega ohms. As I said, you should measure it without RF being applied to it. You should measure the voltage from collector to emitter and should be round about half supply voltage. If it's a little bit less, it's like, for example, it would be 4.5 volts here. If it's like 3 volts or 3.4 volts, everything's fine. I've changed the diode. The diode is now connected via a capacitor and goes with a 1 mega ohm from anode to plus, so it's preloaded. And I've also changed the 100K to 10K. Then I've added a 3.3K resistor on the output from the demodulator in series with a 100 nanofarad. It goes to a simple BC548 audio amp, which has a 1 mega ohm from collector to base and a 10K from collector to plus. Absolutely nothing special going on, and there we have our audio output with a decoupling capacitor and the audio amp. So, okay, in the next video, which I'm going to make, I will tell you some other stuff, and I will also show you if you put in an N-selective circuit in series on the input amplifier, that you can have a quite selective receiver. And I would like to show you that you really can pick up the 470 kilohertz receiver. If I tune this one to 470 kilohertz, and then I do like that, I hold the antenna close to the receiver, I can receive the signal here again. But there are no batteries in there, and I don't have any AA batteries laying around. I have some, but they're original packed, so I don't want to pack them out extra for this. Just trust me on this one. Oh, and something I might try on video. I think it's getting louder if you replace this 22 picofarads. Oh, see? That's 22 picofarads, 68. The camera is probably picking up quite, or it's probably eliminating the loudness, but it's getting much louder. I'm not sure if you can hear it, but it's getting much louder. So if you, the 22 picofarads that you have from one stage coupled to the other stage, if you replace this one with like, this is 100, no, it's not 100, it's 90 picofarads, but replace it with like 100, you will get even more sensitivity. But keep one thing in mind, although the circuitry here looks messed, you can see the long wires here and there, I quite much know how to build this RF stuff on breadboard. Keep the wires short and keep everything like close to ground. So as you can see, for example, here is the emitter, and as you can see between there I have this, between plus and minus I have this 100 nanofarad or whatever it is, capacitor. Okay, Clem, see you in the next video. Best regards, Stefan.